Hey everyone, it's Mr. Morrissey. I hope everyone's having a great day or night. We're looking at solving systems of linear inequalities. We have an objective to graph the solutions to a linear inequality in two variables. Looks like we have a short set of notes just to give you the process. It says graph each inequality. Be mindful that solid lines are the less than or greater than or equal to, and the dotted lines are just the less than or greater than. Shade after testing a point such as 0, 0, or 1, 0. Remember, you can shade the area that includes the test point. Well, remember to shade the area that includes the test point if the resulting statement is true. So just make sure, one thing I would add here is the test point isn't on your line. So you want to have a test point that's an easy number to deal with, but is not actually on your line. Identify regions that overlap. These are your solutions. If there's no overlap, then there's no solution. So again, this is like just a continuation of the work we did with lines. So let's look at this in pieces. So x is greater than -4. Well, that's a vertical line. The SAT people really love those vertical and horizontal lines. So let's see, it's a solid line that goes through x equals -4. And now we have to do the test point. So I'm going to choose 0, 0. So is 0 greater than or equal to -4? That's true. Excuse me. So we're going to shade toward 0, 0. In another line. Oh, sorry. Okay, so there is my graph of just x is greater than or equal to -4. Now we have the second part. So part 2. Y is less than or equal to -1. So another solid line. This is our friend, the horizontal line. Horizontal. So horizontal line at -1. Another solid line. So that's y equals -1. Just to remind you. And we're looking for points that are less than -1. So again, let's test 0, 0. So testing 0, 0, you're only using the y coordinate. Is 0 less than or equal to -1? That's not true. So since we tested 0, 0, we're not going to shade 0, 0. We're going to shade below the line. So let's go here. So I don't know how the shading is going to come up on the iPad, but here is the shading. Okay. Almost done. Now we have what looks like a line. Okay, sorry about that. A student just came by. So now we have a line, dotted line, because it's less than. So hold up, dotted. Okay, so dotted, -4. -4 is the y-intercept. The slope is -2. So up 2 over 1. Up 2 over 1. And I'm going to dot this baby. Here we go. Let's make sure. I look at it visually. I can see I have a negatively sloped line. I can see that I have 0, -4 for my y-intercept. We're looking good. The line's dotted. Now we pause. Remember, you can hit the pause button at any time. And we say, let's test 0, 0 again. 0 less than is -4 greater than 0. Last time I checked, the answer is false. So we're actually going to have shading. Let's see, I'm out of highlighting colors. So that's not good. Those are sort of psychedelic. You guys can see I'm sort of out of choices here. So we're going to have to do, what can I do here, guys? Help me out. So let's just see how psychedelic this is going to look. So you're going to want points that are below this line. So, so this really, that's terrible. But here, let's look for the solution. So we want, just to summarize this, we want points that are to the right, going to the right of the vertical line, below the horizontal line, and the flowers really sort of don't make it the best, but we want below the flowers. So the actual answer is going to be really hard to show, but you're going to have all this area in here. So I just made it, I'm making crisscrosses with blue. So I ran out of highlighter colors. You can see on the iPad we have like, 12 different ones. But it's going to be that swath down in that starts in the third quadrant. Okay? So sorry about using the flowers, but I can't take it back now. And flowers are really, really cool. Actually, let me tell you how to say flowers in Chinese now. Take a break. Hua, hua. So H-U-A, first tone. Hua, 一朵花. Mo li hua, that's rose. Mu dan hua, that's like chrysanthemum maybe. If you know how to spell chrysanthemum, I'd be very impressed because I don't know how to spell it. Anyway, we're getting off topic here. We're 6.5 minutes into this. We've done our first problem. We have a vertical line with a solid vertical line. We have a horizontal line at y equals 1 with a solid line, and then we have the y is less than negative 2x minus 4 with a dotted line. Cool, so the solution is that crisscrossed area. Okay, let's go to number 2. I promise I will not use the flowers. Oh gosh, absolute value graphs. So remember we had this little friend on the last test. We never have done 2 at the same time. So let's graph this. So here we go, vertex. The vertex is going to be 3, 2. And it's going to be upside down. The invisible 1 on the outside here gives you sort of the slope of both branches of the absolute value. So let's plot this. 1, 2, 3, 1, 2. The slope is 1 or negative 1. Here is my graph. Is this a solid? This is a solid line. All right. So there's my upside down parabola vertex at 3, 2. We've done this before, and we are improving on this, but I know it's difficult. Let's pause there. Okay, now let's put in red the second graph, which is going to be dotted. Here's some things I would see immediately. Dotted line. The vertex is 3, negative 1. And the slope is plus or minus 1, the invisible 1. That is a friend of ours, invisible 1. It's very, very, very important. Okay, so let's see. We get 3, negative 1. It's, oh, I should have said it's facing up. And here we go. Oop. No. Follow your own advice here. Dotted. Let's see. Dotted. Okay. There's my graph. We have a dotted line facing up in red, and we have a solid line facing down in blue. Now we need to test some points. So now, this is the hard part. Test points. Remember, pause, rewind, pause the thing, pause the video, and just sort of, reflect on what we're doing. So here we go. We are going to now test. Let's do the work for the blue graph. So I'm going to put the work in blue, and the blue graph I want to test 0, 0. So the blue graph is the upside down one. Oof. Come on. This keeps coming off. So a 0 less than or equal to, this is negative 3 plus 2. Is that true? That's not true. So, and you can see okay. So now I have the blue graph does not, if I plug in 0, 0, okay, it was a false statement. So I actually want to shade not including 0, 0. So I'm shading underneath the blue absolute value because 0, 0, which I'm going to put in green, 0, 0 was over here. So since 0, 0 was above the absolute value graph and we got a false statement, we are not going to shade 0, 0. Now with the red graph, I'm going to test 0, 0. So the red graph, which is dotted, is this. So 0 is 0 greater than 2. Definitely not true. So I'm not going to shade the region that includes 0, 0. So I am going to shade everything above the red line, and the intersection of the red line and the blue line is going to be the diamond. So we'll put it in the intersection. The answer, the solution, is going to be that sort of like diamond shape. Does the red line intersect with the blue line on the MBTA? Let me know tomorrow. Okay, we got 2 more to do. So this is a pretty intense set of notes. Let's look at number 3. It's a lot of graphing, so it's just hard. Let's go to number 3. So y is greater than or equal to x. Okay, that one I think should be relatively straightforward. This is like graphing y equals x. So if I graph y equals x, let's put in a bunch of points. Okay, that's a solid line. There's the line y equals x. I want to do a test point. So let's do a test point of 1, 0. Okay, so is 0 greater than or equal to 1? That's not true. So we're going to shade all the points above the line y equals x. So I'm not going to do the shading right now. I'm just going to put a line in green saying I want to shade above. Now let's go to the second equation. So let's do this one in black. I'm going to convert to y equals mx plus b form. So I have a y-intercept of 1 and a slope of negative 1/3. So down 1 over. Okay, and so this is a dotted line. Okay, so now I'm going to test 0, 0. And I'm going to test 0, 0 in the original equation. Three is greater than 0. So we're going to shade down below the black line. Okay, I'm going to pause here. Okay, now we have one more line to do. What do you guys want to use, green or let's use red. So let's solve for y equals mx plus b. Again, I'm doing now this third equation. Okay, y is greater than or equal to negative 2x minus 3. Okay, this seems pretty straightforward. We've done some really good work with graphing lines. So 1, 2, 3. The slope is negative 2. So up 2 over 1, up 2 over 1, down 2 over 1. So solid or dotted, this is a solid line. Okay. So now I'm going to test 0, 0. Because I can visually see 0, 0 is not on the red line. So, oh gosh, let's see. So now let's test 0, 0. 0 plus 0 less than or equal to negative 3. Some people are wondering where I'm getting this from. It's from right there. So 0, is that greater than or equal to -3? True statement. So I'm going to shade toward 0, 0. So I'm actually shading above the red line. So look, I haven't put any shading in. This is a hard problem, okay? I look at this and I say, okay, I need to be below the black line, above the red line, and above the blue line. So it would seem like that's going to be this diamond, this triangle right in there. And the blue line is solid, the red line is solid, and the black line is dotted. It's a tough problem. Okay, last one. Again, tough set of notes. This one's going to seem a little bit easier, except for the fact that one of the points comes off the graph. So let's see. Sketch the solution of the system of inequalities and find the points of intersection of the boundary lines. So we have a solid line, at, that's a little wavy line, but I'm going to erase that. We have a vertical line at 0, x equals 0. All right. And then look, if you want points that are greater than 0, that's got to be points to the right. We have y is greater than or equal to 0. So that's another solid line with points above the line y equals 0. Then we have y is less than 7. So that's going to be another solid line at 7. That's y equals 7. Now let's solve the last equation. Okay, x over 2 minus 2. Look, the slope of this line is 1/2. The invisible one's important. Okay, so 1/2 x minus 2. So -2 is our y-intercept. The slope is up 1 over 2. Okay, is this a dotted? Okay, they're all solid. So now we've graphed, except for, we have all the shading except for the green line. So let's test on the green line, 2y greater than or equal to x minus 4. Let's test 0, 0. That's true. So we're going to shade up. So we want to shade up and to the right and down. So you can see the region is this sort of crazy looking shape. What is that, a triangle sort of? Looks like it has 3 sides to it. Actually, no. It doesn't include, so I have a couple mistakes. See this little green here? That green, it's actually not a triangle. It's like it's a quadrilateral. Let's find the intersections of the boundary lines. Well, 0, 0 looks like one. And then up here at the y-intercept, that's 0, 7. And then at this pivot point here, 4, 0. Now, here's the hard thing. The last boundary line on the top right-hand corner. That is the intersection of y equals 7 and y equals x over 2 minus 2. So let's write down those two equations. Y equals 7, y equals x over 2 minus 2. To find the intersection of where two lines intersect, you can see you have two equations that are both equal to y. So set both equations equal to each other. So 7 is x over 2 minus 2. We get 18. So 18 is x. That point is 18 comma 7. We knew y was 7, so that's the coordinates, the intersection's y coordinate. Then we plugged in y equals 7, and we got 18. So 18 comma 7. Done. So the solution is the shaded area. So let's really make this clear. All in here. Okay. You might want to ask in class about the 18.7 if you weren't clear on that. Um, but that's it. That was a very tough set of notes. Okay, basically we are done. We just graphed, the objective was to graph the solutions to linear inequalities in two variables, and we were very careful about the dotted lines and the um, solid lines, and we did a lot of test points. Hope everyone's having a great day. Bye-bye.